So now let's take a look at naming ionic compounds, and it's actually quite simple. We write the name of the cation, and then we write the name of the anion. The one thing you want to be careful of is that the cation can have more than one possible charge. Write the charge as a Roman numeral in parentheses. And to help you remember, alkali, alkaline earth metals, aluminum always have the same charge, and silver, zinc, and cadmium always have the same charge. All other metals are going to have more than one charge available to them, and we have to indicate what that charge is by a Roman numeral. So let's look at an example. First, when we are naming an inorganic compound, the first thing we want to ask ourselves is this an ionic compound? And because ionic compound follows the rules we just went over. And to know if something is ionic or not, it's got to begin with a metal. If we look at a periodic table, we find sodium and we find copper. Both of these are on the left-hand side, which means they're metals, which means we are dealing with an ionic compound. Anytime a compound has a metal in it, it is going to be ionic. And so all we have to do is name the cation and the anion. Well, cations have the same name as the element. So this is going to be sodium, and this is going to be copper. Now, the only thing we have to do for our cations is if it has a variable charge, we have to write its charge. Sodium, an alkali metal, always has +1, but copper has a variable charge. So how do we know what its charge is? Well, we use our anion to figure that out. Our anion in this case is sulfate, and sulfate always has a -2 charge. It would really behoove you to memorize the polyatomic ions, their name, the charge, and their formula. So if we look back here, this is going to be copper sulfate. And we've got to say what the charge is. Well, we know that the charge of sulfate is -2. So the charge of copper has to be +2. To cancel that out, there's one sulfate here. This 4 is part of the sulfate structure. It doesn't mean there's 4 sulfates. So this is copper, 2 sulfate. And then sodium, we know, has no variable charge, so we don't need to put its charge in Roman numeral. And then this is chloride. It's a monoatomic anion, and those have the root name of their element and they end in I. So sodium chloride. So let's just look at one more example. And go ahead and pause the voice lecture and see if you can figure out the correct name for this ionic compound. The first thing you need to do is write the name of the cation. And then the name of the anion. That was oxide. And then, because titanium has a variable charge, it's not an alkali metal, it's not an alkaline earth, it's not zinc, silver, or cadmium, we've got to figure out what its charge is. And we do that by looking at our anion. Oxide always has a -2 charge, and we can also remember that by looking at the periodic table. Oxygen is 2 columns away from the noble gases, so it's going to have a -2 charge. So our titanium oxide has 2 oxides, so that is a total of -4. So therefore, my titanium must have a +4 charge on it to cancel it out. So it's going to be titanium 4 oxide. And just a reminder of the Roman numerals, that's 1, that's 2, that's 3, that's 4, that's 5, and that's 6. We're not going to go above 6 for the charges. Now, I mentioned that it's a good idea to memorize the polyatomic ions. Let me just give you a few hints that might help you. For example, if we look at nitrite and nitrate, or sulfite and sulfate, they look very similar, and they are. There's just a difference of 1 oxygen. The anion with more oxygens ends in the 8. So NO3 is nitrate, NO2 is nitrite, SO3 is sulfite, SO4 is sulfate. And then we also have oxyanions, meaning anions that have oxygen in them, that have 4 different possibilities. And we see this with chlorite, chlorate, hypochlorite, and perchlorate. So the one with the second fewest oxygens ends in the ite. So here we have chlorite and bromite. The one with the second most oxygens ends in 8. So chlorate and bromate. The one with the fewest oxygens has hypo. So this is hypochlorite, hypobromite. And the one with the most oxygens has a per. So perchlorate, perbromate. So there's really not a systematic way that these oxyanions were, where their names were developed. So this is just a little ragtag help that might assist you in memorizing the name and the formulas.